So we started section 1.4 last time, and we had defined how we're going to be using a unit circle and how that sort of interplayed with the other definitions we'd had for sine, cosine, tangent, secant, cosecant, and cotangent. And we had these definitions. And they're all based on a unit circle. So a unit circle has a radius of 1. That's important. Otherwise, these won't make sense, right? And you've got the x-coordinate and the y-coordinate, and then you have reciprocals of them and so forth as you work your way through. So all of that stuff we did before, and we did this example. And we talked about this is a unit circle. It's got this x-coordinate and this y-coordinate down here. And then we can define sine, cosine, tangent, and then their corresponding reciprocals using just those two values. We don't need a radius value because the radius is 1. Okay? All right. The unit circle is what's next, the standard ones that we see on the unit circle. So this is our image, and you'll need to memorize this. And until you have this memorized, make sure you have it with you because you're going to be studying it from it. And this is actually what our quiz is on Friday, the more substantial quiz. So let's talk about what's going on in this unit circle. So on this unit circle, we're just going to start in quadrant number 1. If you can memorize quadrant number 1, which you know you can, then the rest of the quadrants come straight out of quadrant number 1. Okay, so I want to look just at the ordered pair coordinates around the side first, and we'll do just quadrant 1. So up here in the top quadrant, the first value, we'll just start over here on the positive x-axis, is the value 1, 0. Okay, so we're at an x value of 1 and we haven't gone up any, so that's the value 1, 0. I'm talking about these points on the edge. Okay, the next one over here is going to be square root of 3 over 2 and 1/2. And the one after that is square root 2 over 2, square root 2 over 2. And to be honest, if you have those two values, I mean, I guess you could say 3 if you want to talk about the 1, 0, 1, but those two values with the radicals in it memorized, the rest of the circle is just moving things left and right, up and down from there. So the third one in quadrant 1 actually takes the first one I wrote and it flips it. It's 1/2 and then square root 3 over 2. I'll describe where these came from in a minute, but... What's that? Yes, it is. You're right. And we're going to get to that. So what is this point on the top of the circle? Okay. Okay, those are the values for the angles. What's the point? 1, 0. Sorry, 0, 1. I said it backwards. So sorry. 0, 1. Okay. X has not gone left and right any. We went up 1. All right. And then here's the thing, this coordinate, right, this quadrant, I can just flip it over and I'm going to have the same values over here, but there's going to be some negatives involved. Which values are going to be negative in that quadrant? Okay, so we're thinking ordered pairs still, so the x values. Okay, so the x values. So everything is going to be a mirror image from right to left, and it's going to be the x values that are going to be negative. So over here, I still have the 1/2 and the square root 3 over 2, but my x value is negative. And I still have square root 2 over 2 and square root 2 over 2, but my x value is negative. And I still have square root 3 over 2 and 1/2, but my x value is negative. Right? Okay. What is this one over here, this corner, this quadrantal angle? What's the point? -1 and 0. Okay, so this is -1, 0. X value -1, don't go up any for y value 0. Now we're going to take the quadrant 2 and we're going to reflect it down into quadrant 3. Going to have all the same ordered pairs except for what's going to happen with the x and the y signs now. They're both negative. Everything's negative down here in quadrant 3, right, in terms of the x and y's. So I'm going to flip it down. So again, I'm still going to get square root 3 over 2 and 1/2. I'll put the negatives in a minute. Square root 2 over 2 and square root 2 over 2. And yeah, I was writing it right. 1/2 and then square root 3 over 2. And like you said, the x's and the y's are all negative, so we have negatives on each of these. All right, what is the value of the ordered pair down here?
0.
That is 0, -1. Right? okay? Now we're going to do the right coordinate, or the quadrant 4 over here. So you can think about flipping quadrant 4 from quadrant 3, or you can think about flipping quadrant 4 from quadrant 1. It doesn't matter. All the values just repeat themselves, right? X, Y, which is negative in quadrant 4? Y. Okay, X's are positive, Y's are negative. So we have, again, 1/2 square root 3 over 2. We have square root 2 over 2, square root 2 over 2. And we have square root 3 over 2 and 1/2. And all the Y's are negative. Okay, so these ordered pairs form the points on the edges of the circle. Everybody good with that? The other thing that we want to know from this circle to actually be able to use it is the angle measures that are showing up, which is what you were leading up to. So each of these angle measures, again, are going to repeat in sort of variety. So I want to start with the ones that are the square root 2 over 2's. Can we start with those? I realize that's not going exactly in order, but I think those are a good place to start. So if we take this first one right here to here, this is pi over 4, or 45 degrees. Okay, it's halfway, right? So all the way is 90, right? If we go all the way to the top of the circle is 90, that's halfway. That's my halfway mark. And if I go over, and I'm going to write it, I drew it in like that, but I'm going to actually write it along the side here. So this is pi over 4 and 45. Is that okay visible-wise? It looks really fuzzy. Let me make my pen a little bit smaller. Okay, are we good with that? Okay, and I mentioned this one, of course, which we knew was pi over 2 and 90. So the next halfway mark, right, at the square root 2 over 2 over here, how much should that one be? Okay, it's going to be 3 pi over 4. What's the degree? What's that? We want to add, yeah, so you're thinking in terms of radians. Let's do the degrees, which most of us are probably a little bit more comfortable at the moment. What is it? 135. So this one over here is 135. And you're exactly right, it's 3 pi over 4. And we are adding 2 pi every time. So this is not 2 pi, but we're adding a 2 on top. Right, so we go from pi over 4 to 3 pi over 4, right? The 1 became a 3. And then if I go down here, this next one, my left side, you know, that's what degrees? 180. And what is my radian measure over here? It's just pi. Maybe I should have filled those in first. Let's fill the bottom one in, then we'll go back and get those 45 degree ones. What is the one down here at the bottom? It's 3 pi over 2. I should probably at least be consistent with my angle. I keep turning my iPad out. Let's go like this. 3 pi over 2 and 270 degrees. Okay. So those are my quadrantal angles. I can go all the way around over here too. This is both 0 radians, which is 0 degrees, and it's also 2 pi radians, and it's 360 degrees, right? To go all the way back to the beginning. Okay. All right, let's go get those 45 degree angle ones now. All right, so 3 pi over 4, if I come down here, will be what?
225 degrees.
How much?
225 degrees equals 5 pi over 4.
225 degrees. And then we went from pi over 4 to 3 pi over 4, and now we are at 5 pi over 4. Okay. So if we do 225 plus 45, we get 270. If we add another 45, we get over here, 315. And then what is my radian measure for this, right? So this went from 1 to 3 to 5. It will be 7. 7 pi over 4. Okay, everybody good so far? So if you're using those 45 marks, you can add the 45 degrees or the number 2 on top each time to get those 4 pieces. All right, the next thing I'm going to do is I'm going to take a look at the ones that are closest to the x-axis. Okay, so in my picture, that's this first one right here. This is what I'm talking about. Okay, this mark right here is I'll do it this way. It's a 30-degree angle. Okay, it's 30 degrees. And the one up here on the top that I'm missing is 60 degrees. So they're 30, 60s. So these are coming from, we saw this back in section 2, those 45, 45, 90 triangles and the 30, 60, 90 triangles. That's where they're coming from. Those friendly triangles where we had these nice values showing up. So this is 30 degrees on the first one. 30 degrees is pi over 6. And then 60 degrees is pi over 3. And you can kind of think about them flip-flopping, right? You have over 3 and it's 60. You have over 6 and it's 30. So if that's a helpful way to think about it, you can. And then we can go over here. And we're going to go on the quadrant 2. And I'm going to look again closest to the x-axis. So if this is pi over, actually, let me just do the 30-degree part first. If this piece is 30 degrees, so is this one. Agreed? Right, there's a mirror image going on. So if I go back on the left side and go up 30 degrees from 180, where am I? We're at 150, okay? So this mark right here, I don't think I went too far, is 100. Yeah, that's okay. Is 150. Okay? And it's 5 pi over 6. You're right. So we go up or subtract off a pi over 6 from the pi measure. So it's pi over 6. So the ones that are closest to the x-axis are all over 6 values. Okay, so we have pi over 6 on your right, and you have 5 pi over 6 on your left that are closest to the x-axis. The ones that are closest to the y-axis are over 3 values. So we actually have pi over 3, which we already did. And the other one up here is actually 2 pi over 3. Any idea what the degree measure should be? It is 120. It's double what the 60-degree one was. Okay? So it's double. It's gone, if you want to think about this has gone 60. This has gone double 60, so it's 120. That's what's happening there. The pieces down below, we're going to just kind of think pattern-wise, because that's how you're going to think about this later anyway. You don't want to actually have to figure out each of these values every single time. That's not going to be worth the time to do it. But looking at the patterns that are going on, we should be able to fill the gaps. So if this one was 5 pi over 6, what's this one going to be? 7 pi over 6, right? It's still a pi over 6 value, and it's one more than it was the other direction. So this one is 7 pi over 6. And if I add 30 degrees to the 180, I get 210. I'm going to jump over and do quadrant 4 in that same spot. So do you know what this radians? It's going to be something over 6, something pi over 6. It is 11 pi over 6. So if you take 12 pi over 6, that's the same as 2 pi, and subtract 1 from it, you get 11 pi over 6. And if you take 360 degrees and you subtract 30 from it, you're going to get 330 degrees. We only have 2 left. They're at the bottom. They're over 3 values, right? That's what's left. The values nearest the y-axis are all going to be some value of pi over 3. That's going to be one of them. Do you know which one it is? The one in quadrant 4 is 5 pi over 3. What's the one I'm missing in quadrant 3? It's 4 pi over 3. Okay, so if you take a look at the pi over 3 values, we went from pi over 3 to 2 pi over 3. Where would 3 pi over 3 be? At the 180 mark, okay? So it's there. It's just that we would be more conveniently writing it as pi. 3 pi over 3 is pi. Then we have 4 pi over 3 down here in quadrant 3. And then 5 pi over 3 is over here in quadrant 4. And then where would 6 pi over 3 be?
36.
Back at the 360 degree mark, right? All the way around. Okay, so they're adding pi over 3 every single time we're going. So this is 5 pi over 3. 4 pi over 3. What is that degree measure? Yep, it's 240 degrees. I'll show you another thing that you can look at in terms of the sides here. Notice what's happening as we go from, let's use yellow, 210 to 225 to 240. How much do we add every time? 15. That's not a coincidence. It's 30 away from the axis, right? Like I went from 180 to 210 by adding 30. But all of those ones that are bunched up in the middle are all 15 apart. Okay? So if you can get one, you can get all three because you're just adding 15 each time. What about 5 pi over 3? What should that one be then if we have that idea of adding 15 each time? It's 300. Why 300? Well, if you're thinking from what I was just talking about, I'd subtract 15 to get back to it, right? Okay. So, you need to memorize the circle. You don't have to memorize the whole circle to be able to figure out the rest of it. But if it's helpful to you to just say, I'm just going to memorize every little piece on the circle, then by all means do it that way. But the bare minimum to make this work is to memorize your ordered pairs on the tops and left and right. Those are zeros and ones and ones and zeros. That's fine. And then these two x values right here. Right? Not x values, but ordered pairs, excuse me. If you know those two ordered pairs, you can get all the rest of the ordered pairs by flipping things around and negating and stuff, right? And then these angle measures are either increasing by pi's over 6, pi's over 4s, or pi's over 3s. All right, they're increasing by 15 degrees or 30 degrees each time. There's patterns all over the place here. So I've been talking to my kids lately about the fact that math is not numbers. That's a part of it. It's a big part of it. I agree. But math is not just numbers. And I may have even said this in here to you guys before, is that, if you thought that grammar was all there was to English, that'd be a very, very narrow view of what English is all about, wouldn't it? There's so much more to English than just grammar. There's so much more to math than just numbers. But one of the big things that I feel like math is its patterns. It's also problem solving. It's also logic. There's lots of things, but it is patterns. And this is a really good example of there being just so many patterns at play that will help you to remember all the details. All right, so why are we doing this? Well, we're doing this because it makes it easier to find the sine, cosine, tangent, secant, cosecant, cotangent values of any of these angles. And these are the angles that show up the most. And that's the deal. So we're going to keep flipping back and forth as we move forward in this section between this image and all the rest of the problems. Okay? So here's our first one that we're going to do. It says to use the xy coordinates in the figure below. It should say figure above. That's a typo. We'll fix that later. To find the value of each trig function at the indicated real number t, or state the expression is undefined. So the angle that they're talking about is this t. So this is the angle t that they're referring to. They use thetas a lot of times, and your book uses t's a lot of times, okay? So cosine of 2 pi over 3. Well, we come back over here, we find 2 pi over 3. So we're going to find it. It's right here, right? This is 2 pi over 3, and this is the ordered pair associated with it. Now here's how I remember which one's cosine and which one's sine. It's alphabetical. Cosine comes before sine, C before S, and X comes before Y. That's how I remember it. So X goes with cosine because they both come first. Y goes with sine because they both come second. So you're looking at this ordered pair, and you're asking yourself, what's the cosine value? And the cosine value is simply the X value. So what is the X value that's currently circled? -1/2. And because we have this picture either in mind or on paper next to us, we're able to answer this question very quickly. This is -1/2. Cool? Okay, so the work is on the front end, the learning of the unit circle. The payoff is on the back end. All the problems are really fast. Okay, here's the next one. Tangent 3 pi over 2. Well, this one's a little harder to do. In general, tangents are harder to do because you can't just read it straight off of the graph, right? You actually have to coordinate and figure. So tangent is what?
Sine over cosine.
Sine over cosine, or we defined it as well as y over x. So either of those versions are fine. Now at 3 pi over 2, we are down here, right? This is 3 pi over 2. The y value is -1 and the x value is 0. Everybody good so far? So when I'm looking at writing this down, I would have -1 for y and 0 for x. That's what those values give me. But what is -1 over 0? It is undefined. So the answer is that this is undefined Let's just put U and D since I'm out of space. It's undefined. Okay, you ready to try a couple more? The next one wants the sine value. Sine value is corresponding to what? Y. So this is asking us for the y value. I'm going to write down y here as a reminder. Maybe I should have done that back on cosine, but I didn't. And it's telling us to go to 5 pi over 4. Where is 5 pi over 4? Third quadrant. It's right here, and this is the ordered pair. Sine is y. What's the y value that's been circled? Negative square root 2 over 2. Right? Yeah, that's the one. So this answer is simply negative square root 2 over 2. Isn't that lovely? It's pretty friendly. I mean, I get that there's a price to pay at the beginning. There usually is. All y'all are athletes. There's a price to pay to play well in the game, right? It's called practice. If you don't enjoy the practice, it's not going to go well. Yes, ma'am.
Is it not the negative 3?
So for 5 pi over 4, we're right here. The square root 3 over 2 is down here at the 4 pi over 3. Double check and make sure that you don't have it written backwards. That's possible. Yeah, good question. Because if we memorize the circle wrong, we're definitely going to have some wrong values showing up. Yeah. Okay, cotangent of 13 pi over 2. Now, this is kind of a problem because there's no 13 pi over 2 on my unit circle, correct? Okay, so we talked about reference angles, right? Do you remember doing that? I think it was in section 3, but it might have been section 2. They start to run together. Yep. All right, so 13 pi over 2. And to do a reference angle, it means we subtract 2 pi each time. 2 pi, though, needs to have a common denominator. So what would the denominator be for these two to match? It'd need to be a 2. So I'm going to rewrite this instead of saying 13 pi over, instead of saying 2 pi over 1, I'm going to end up with a 4 pi over 2, right? So what is 13 pi minus 4 pi? 9 pi over 2, which is still not on my circle. Okay? Well, so we just do it again. 9 pi over 2, and we'll subtract another 4 pi over 2. And we get 5 pi over 2. Is that on my circle? Not yet. We're close, though. 5 pi over 2 minus another 4 pi over 2, and we're at pi over 2. That's on my circle, right? Once I've subtracted off 2 pi enough times, I'm back where I want to be within my circle unit, my circle values. So I'm at pi over 2. So, pi over 2 is where?
90.
Yep, 90. It's at the top, right? And this is supposed to be cotangent values. Okay, so cosine over sine or x over y. Either of those versions are perfectly fine. What's the x value over here?
0.
It is 0. And the y value? 1. What is 0 over 1?
0.
That one's 0. Okay, the last time I had 1 over 0 or negative 1 over 0, but it was undefined, right? This one's 0 on top. That's perfectly fine. So the cotangent value is 0. Okay, our last set of identities in this section is showing up, in this whole chapter, I think, actually, is showing up right here. These are even odd identities. Even and odd will come into play a bit more when we get into chapter 2 with the graphs of sine, cosine, tangent, which come from the unit circle. But for starters, even and odd trigonometric functions have to do with whether or not you have the repeating values being negative as things move around, like they flip signs, or whether the signs stay the same in certain ways. So let's write these down first. Cosine and secant are even. Cosine and secant actually have the property that the cosine of negative t is the same as cosine of t. And the secant of negative t is the same as the secant of t. So a negative angle inside is irrelevant. It's kind of like when we square negative numbers. It doesn't matter that they were negative. You square them, the negative goes away. But when you take the secant or the cosine of a negative angle, the negative doesn't matter. Now, that's only true for cosine and secant. All of the others are in a different category down here, and they're called odd functions. And what it means for them to be odd, again, has to do with how the negatives show up as we work our way around the circle. And for the 4 at the bottom, what happens is we get the opposite value. So this is the negative sine of t. This is the negative tangent of t. This is the negative cosecant of t. And the negative cotangent of t, which is terrible notation because now my cotangent t and the t are right next to each other, which looks terrible. But nonetheless. Okay, so the negatives don't go away. They kind of look like you're plucking them out and putting them in front. You're not, but that's what it looks like, right? Looks like the negatives just moved locations. So what this does is this allows us another option to use the unit circle without doing it as reference angles. Now, this one would have been still done with reference angles because this 13 pi over 2 wasn't negative, right? I mean, so it doesn't have to do with any of that. But these over here have negative angles, correct? So one way to do this with reference angles would be to add the 2 pi, and we could do that. There's nothing wrong with that. But another option is to use an even and odd identity. So what does that look like? Well, we can do cosine pi over 3 from the circle just fine. So let's start there. Cosine, is it x or y? It's x. Do you see pi over 3? Okay. What's the x value at pi over 3? It is 1/2. We're right here. Okay. So at pi over 3, I'm at 1/2 square root 3 over 2. The x value is 1/2. So over here, from the unit circle, this is 1/2. Straight out, nothing identity-wise going on there. It's just the same as we did before. But because I have even and odd identities, right, what this actually allows me to say is, okay, but cosine is one of those top ones, right? It's even. And when I have a negative inside of a cosine, it's irrelevant. It doesn't matter. And I'll look at the unit circle with you to sort of justify why that's the case here in a second. But this is actually exactly the same as just cosine of pi over 3. Right? That's what this identity says. Cosine of t and cosine of negative t are exactly the same. So if I have cosine of negative pi over 3, that's the same as cosine of pi over 3, but I know what cosine of pi over 3 is. Just found it. It's 1/2. So I don't have to go through the process of doing it with a reference angle when I've got even and odd identities now at my disposal. Now let's do it with reference angles just so you can see it works, because I'd like for you to see that it's the same value. If I were doing this with reference angles, I would need to add 2 pi to this. 2 pi over 1, I would need there to be a common denominator. So this would be the same as having negative pi over 3 plus 6 pi over 3, which would give me 5 pi over 3. Everybody good so far? Yeah? Okay. So over here, look at your unit circle. Do you see 5 pi over 3? Do you see it? It's down here, right? What's the cosine value at this point? That's the sine value. It's 1/2, right? This is the cosine value. The x value is 1/2, just like it was at the top at pi over 3. Okay. So whether we do it by reference angles or whether we do it using even odd identities, we're going to get the same thing. Now think about this from the even odd identity perspective. This one is pi over 3, correct? Well, 5 pi over 3 is also the same as going this way, negative pi over 3. Remember, positive angles go counterclockwise and negative angles go clockwise. But the x value in each of these locations, if I'd drawn it well, which doesn't look like I have, it's not too bad, is supposed to be the same distance to the left, right? Or right, sorry, right from your perspective. It's the same distance to the right. It's the same x value in that location, whether I went up or whether I went down. And notice all of the x values do that, right? They do. It doesn't matter if I'm at pi over 3 or pi over 6 or pi over 4. They're all going to do that between quadrants 1 and 4. But if I do this for sine, they all switch, right? All of the sine values are the same number, but the opposite sign, right? So look at the two I just picked. If I look at the sine value at pi over 3, it's square root 3 over 2. But if I look at the negative, right, down here, this negative angle, it's negative square root 3 over 2. Right, and that's what the even and odd identities are playing on, is the signs that are happening around the unit circle. All right, sound good? Okay.